Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets. Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter, every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system, 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities, another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between two colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then, people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of 100 years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller, but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there.
Hey, look up! There's a meteor shower happening right now! Okay, not really, but I made you look. If you're a fan of full moons, there's one coming up very soon, on February 27th to be exact. I really hope this video comes out in time. The moon will be lit up right in front of our eyes because it will be located on the opposite side of the Earth, where the sun is. It will help illuminate the moon, providing us with a night to remember. Take a good look at it. Doesn't it sort of resemble a huge snowball just hanging from the sky? Some native tribes in the northern hemisphere of our planet might have thought the same. That's why they used to call it the snow moon. You know, when it was big and full, like this. Okay, go ahead and grab a telescope now, because on the 9th and 10th of March, there are 3 planets that will line up for your aesthetical pleasure. Starting from top to bottom, you'll see Jupiter, then Saturn, and last, but surely not least, Mercury. Now, depending on how good your telescope is, and if you've even got one, chances are you'll see some details of these 3 planets. You adjust your telescope a bit, and there it is, another planet. Almost like they're not thousands and thousands of miles away from each other. But that's not all. They'll be visible to the unaided eye too. This means you won't even need a telescope. Well, you'll probably see them like this, 3 bright white balls in the sky. Still astonishing though. You'll need to be looking at the southeast around half an hour before the sun rises, and voila! There they are. In the mood for a relaxing shower? How about a meteor shower instead? This time, you can keep your telescope safely stored, and you don't need to worry if you miss 1 or 2 of these showers, as there are quite a few happening this year. They're pretty evenly spread out too, and I don't mean the meteors. Those come close together. Grab your calendar and put a reminder on these months. You can choose from April, August, October, November, and December. Some months even have 2 showers instead of only 1, like October and November. Choose the month and day that works for you. Just check your calendar again. If you don't mind it being a bit chilly, just wrap yourself up in a blanket and hop in the back of your pickup truck. Then, all you have to do is stare up and enjoy the sky all night long, waiting for the shower to happen. Or, if you like to work by the clock, set up an alarm to wake you up in the middle of the night. That works too. Mercury's coming right at you! Watch out! Nah, don't fret. It's still right up there, just a bit closer than usual. That's because on the 17th of May, it'll be at its greatest eastern elongation. What this means is it will be easier to observe. Right after sunset, point your eyes to the skies in the west and try to look for the planet. This happens again during the 4th of July, but this time you'll have to look to the east. You might need a compass. Start your celebrations early in the morning, just before the sun rises, with a gorgeous view of Mercury, and of course a cup of coffee in your hand. If you still don't catch it then, try September 14th or October 25th. How about when the moon loses its natural white color? This happens just a few days after Mercury's first performance on May 26th. It's called a total lunar eclipse. The moon will get gradually darker, as if someone was dropping dark red paint on it, until it finally reaches this sort of rusty red color that you can see on the screen. Not all of us will be able to see this unless you're on a cruise in the Pacific Ocean or in the calm fields of Eastern Asia. If you live next to the Tokyo Tower, you're in luck. It'll be visible throughout the whole of Japan. And if you happen to live in the western part of North America, you'll also be able to see the moon shapeshift. Well, not quite shapeshift. It's not going to turn into a wolf or anything. That only happens if you're a werewolf, which I definitely am not. So it's more like a color shift. Still, on the moon, picture a massive black hole. Well, this next astronomical event kind of resembles that. On June 10th, during the annular solar eclipse, the moon will be the furthest it ever gets from Earth. While it's doing this, it ends up covering most of the sun, leaving just a bit of its curvature for us to see. If you happen to look at the sky during this time, what you'll see is a massive ring of light. Chances are you won't be able to tell that's the moon out there, since it'll be the same color as deep space, the absence of color, or just a very deep black. Oh, and that ring you're seeing? That's the sunlight. Okay, since we're talking about rings, I've got one for you, Saturn's ring. This planet is the full package. It's a planet, it has a ring, and get ready for this, it has 82 moons. It feels like every year a few new ones pop up out of nowhere. Anyway, during August 2nd, the planet will be at its closest point to Earth, and the sun will help us catch a good sight of it by brightly illuminating it. Not only will it be brighter than it ever is during the whole year, but it will also be visible all night long. This is the time to get that telescope ready again. A medium-sized one should do the trick. That is, if you want to see its rings and some of its moons, the ones that shine the brightest. Another planet that's coming closer is Jupiter, this time on August 19th. The same thing that happened to Saturn will happen to it. The sun will shine bright on its big planet face. The only difference is that this time, if you have a good pair of binoculars lying around, you'll be able to see the planet's 4 largest moons. Although they'll look like tiny dots, but now you know what they really are. Okay, so you've been thinking about those meteor showers I mentioned earlier. Well, this one is the best there is. It's called the Perseids meteor shower, and it almost looks like the sky is a pitching machine, except it's pitching meteors. During this particular shower, you might even be able to observe up to 60 meteors per hour. They're very bright too. Look at them go! Zoom! There goes another one. The best days to get cozy, sit on the grass, and just lie there looking at the sky is during August 12th and 13th. Usually, when these 2 days come around, the sky's dark and clear, perfect for a meteor shower. Picture a slightly red moon. That's called the partial lunar eclipse, and it happens during the 19th of November. This same red moon will get darker and darker as it moves through Earth's shadow. It won't be visible to everyone though. Here's a globe. Let's mark the places where you can see this partial lunar eclipse. First, we got Eastern Eurasia, then Japan. The Pacific Ocean's included in this list too, but unless you got a boat, you're likely not going to be there. Then we've got North America, Mexico, Central America, and lastly, some parts of Western South Africa. Grab a hold of your eclipse glasses and get ready for this last one. It's the last solar eclipse of the year. This one in particular is the best one to catch, as the moon will block the sun for almost 2 minutes. You'll be able to see the almost ghost-like sun's corona, also known as its outer atmosphere. The sad part is, you'll have to be in Antarctica or the South Atlantic. Just be careful out there. I heard it gets a little chilly.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water, should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand. others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing towards the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. Two of them, Pandora and Prometheus, flank the F-ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But two of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying.
Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon, and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, We use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask. But you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere. But you packed a sweatshirt, right? It's gonna get pretty cold soon, like -300 degrees cold. The coldest it ever got on Earth was -128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're going to send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're going to have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. It takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission: to find a nice place for us to settle down in. but creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle, energy production. Probably some sort of nuclear power plant. Then comes shelter, for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem, gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that.
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its two host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star. Not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
A huge meteorite enters our atmosphere, causing an explosion of catastrophic proportions. All forms of life on Earth cease to exist. A giant wave of fire wraps around the planet several times until only ash and dust remain of the green landscape.
But then again, there's another option for our planet's future. The sun could swallow it.
Wait. Who is this?
In the course of its evolution, our star will keep expanding.
Am I the only one hearing this voice?
Until it gets so big that it just swallows our planet without even noticing it.
Hey buddy, that's my video.
I don't think so.
Okay, alright, I'll share it with you. But let's not look that far into the future.
Whatever you say, buddy. How about the fact that the Earth will soon have rings?
Like Saturn?
Almost. Saturn's rings are made of dust and ice.
Yeah, I've heard about that. Thousands of years ago, something really mysterious happened in Saturn's orbit. The planet's gravity tore one of its satellites apart.
Yes, Saturn is a gas giant. It's 95 times heavier than Earth, so it has stronger gravity. It attracted a small moon from its orbit to its surface. Then, it was torn apart from the inside by tidal forces, like the ones between Earth and Moon. Many huge fragments stuck in Saturn's orbit. Some scientists say there was a collision of two moons there. They crashed into each other like billiard balls. As a result, both cosmic bodies turned into a pile of debris and blocks of ice.
No matter how they got there, this debris started circling Saturn. They collided with each other, turning into smaller rocks. It was a kind of cosmic blender. Rocks gradually ground into dust, and huge blocks of ice turned into small crystals. On average, the objects are in the same ratio to these rings as a human fingernail to a school bus.
And soon, similar rings will appear around Earth.
But how? I mean, we have the moon, and it's hard to imagine that it could break apart at any moment. Plus, we don't have another moon to recreate the same collision in our orbit.
Space junk. We have a lot of it. We started launching spacecraft into Earth's orbit in about 1957, and it almost always follows the same scenario.
Ah, yes. The rocket consists of several parts, a booster, or even several of them, the second stage of the rocket, and a cargo, which is contained in a capsule at the end of the rocket. The booster accelerates the rocket to almost orbit and then undocks. The second stage fires up the engines and climbs even higher to get the cargo into orbit. Then the second stage undocks as well, and the cargo capsule releases the satellite or space probe into outer space.
Yes, the first and the second stages of the rocket and the cargo capsule were disposable. That means they stayed in Earth's orbit. Over time, our planet attracted them. They entered the atmosphere and burned up because of friction with the air. But many objects keep orbiting our planet for decades. As of 2021, there are about 170 million space debris objects in our orbit. These are parts of spacecraft, like the bolts used to undock rocket stages. There are also old artificial satellites, operating ones, functioning spacecraft, and debris from collisions that had already happened.
Oh, I've heard about that. In 2009, two satellites collided with each other. Both satellites were destroyed. They shattered into about 600 pieces of different sizes.
Yes, and these sharp metal fragments are flying in orbit at about 6 miles per second. So they could make a trip from New York to London in less than 10 minutes.
Yeah, that's about the same speed at which our rockets fly. And that's about 45 times faster than commercial airplanes.
So these fragments have a lot of energy. As they collide with each other, they shatter and become smaller.
Just like the moon debris around Saturn.
Exactly.
But a bunch of metal debris orbiting faster than the speed of sound can damage our spacecraft, right?
Yes. The International Space Station has already turned on its engines to maneuver once to avoid a collision with a cloud of space debris. Sharp metal parts can damage the hull of the space station or even puncture it. Then the ISS, worth about $150 billion, would be destroyed.
So, if we keep throwing debris into orbit, we could really give our planet the rings.
And then they will be visible even during the day. They will reflect sunlight, just like the moon. And if you look out the window, you'll see beautiful stripes interrupted by the shadow that the Earth casts.
It's an amazing view. Do you want to see an even more unusual one? Imagine that our sun has increased in size by 10 times, and that process is happening right now. Our star is a giant boiler burning hydrogen. It's continually heating up, and every billion years, the sun gets 10% brighter and creates more heat. It'll heat the Earth more, and eventually, the oceans and seas of our planet will begin to evaporate. Thick clouds will completely cover the sky, turning Earth into a giant greenhouse. Our home will look like Venus.
Looks like humanity will no longer be able to live on Earth. What will we do then?
Well, we'll load all the humans and animals into spaceships and move to Mars. At that point, the sun will have warmed it up nicely. Water and carbon dioxide deep in the planet's interior will begin to evaporate and create an atmosphere there. This will cause a greenhouse effect and warm up the planet enough for you to wear shorts there.
And then we'll watch the Earth become a lifeless rock with acid clouds like Venus from the surface of Mars.
Yep, but in about 7 billion years, the sun will start to expand even more and become a red giant. In this phase, it'll become 256 times wider than it is now. So it will completely swallow Mercury and Venus, and the edge of the star will lie just in the orbit of Earth.
So our planet will just drown in the hot plasma on the sun's surface?
Maybe. But when a star burns so much fuel, it loses weight, and so the sun's gravitational field will weaken as well. So it won't keep the planets of the solar system as close to itself anymore. Perhaps our planet's orbit will become wider, and then Earth will become the first planet near the sun. Some scientists believe that, at this time, Saturn's moon Titan may gain conditions suitable to become a new home for humanity. Then the sun will begin to shed its upper layers. It'll lose mass and gravity dramatically. This will plunge the solar system into chaos.
Some planets will collide with each other. Others may just fly away into the far dark space. It would be a game of cosmic billiards.
Exactly. And the final stage of the sun's life is a white dwarf. Then our star will become the size of Earth. The planets that survive won't get enough heat from the white dwarf, and its light will gradually fade over billions and trillions of years.
Another challenge that awaits Earth in the distant future has a galactic scale.
The collision of the Milky Way and Andromeda.
Bingo! Right now, the Andromeda galaxy is moving toward us at 60 miles per second. You could make a trip around the globe at that speed in just 6 minutes.
Yeah, you can already see the stars and gas of Andromeda Galaxy in the night sky with an unaided eye at 2.5 million light-years from Earth.
And in 4 billion years from now, the galaxies will begin the process of merging. No one could be 100% sure about what will happen to the Earth. It could be total chaos when the stars and nebulae of both galaxies collide. Then supernova explosions would go off everywhere. Like fireworks.
But this is extremely unlikely to happen. The concentration of stars and space objects in galaxies is very low. The distances between them are gigantic. It's like if you took a handful of sand and scattered it all over the planet.
The most likely scenario is that by the time the two galaxies do collide, there will be no liquid water on the hot surface of Earth. That would mean the end to all terrestrial life. Scientists believe it can happen in about 3.75 billion years.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation – phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.